So now that we have our tool tight in the holder and our tool is in the spindle in the correct pocket of our mill, we're ready to begin taking our tool length. The way that I like to take my tool length is by finding the distance between the tip of my tool and a theoretical plane on the milling machine. In order to find that theoretical plane, I like to come to a dial indicator. Before we get started, I'm just going to wipe the bottom of this dial indicator off because this is going to become a reference location that all my tools are going to touch off on. Now, one question I get asked a lot is this a way that you would do your tool length offsets in industry? With the new probing systems that are on a lot of the new machine centers, this is in fact how they determine their tool lengths. The tools touch off on the top of a probe, and then we tell from the top of the probe to the top surface of our workpiece. So I want to put my dial indicator on the table of my bed, and right now, because I haven't touched off any tools, I can set my dial wherever I want. I want to have it so that my zero is far away from my needle. That way when I touch or bring my tool down, I can watch my needle move around my indicator. So now that I have my indicator on the table, I'm going to bring my tool to the indicator and come down on top. I'm going to do that with my pendant controller. So I'm just going to move my axes. Obviously right now I'm moving my X. I'm going to move my Y into place. And I'm just going to kind of bring it above, or bring my tool just above my dial indicator. Now I'm going to start coming down. Press that over. And I'm going to make sure my tool is somewhat in the center of the plunger on the dial indicator. Now, as soon as my tool touches that indicator, you will see that it is starting to move. My needle has moved, and as I continue moving down, my needle will continue moving around the outside of my indicator. I want to bring this so that my tool is down far enough and my indicator is reading 0. This 0 location on my indicator will become my theoretical plane. So this is the height that all my tools are going to come to. So every tool I bring down is going to come and push on my plunger until my indicator reads 0. Really what I am measuring right now is the distance my machine has traveled from the machine home Z position to my indicator plane. How can I find out what that number is? Well, really easy. I can come over to my NC controller, and my little numbers, which have home beside them, so my home Z, is telling me that I have moved minus 12.0944 from my machine home position down to the position my tool is in right now. I want to input this minus 12.0944 into my tool length offset page. In order to do that, first I need to remember what this number is. A nice way to do this is, you all have cell phones. I know you all love using them. Take a photo of this number, and then you have a reference of what this value should be when you input it in your tool length number. I'm just going to use memory, minus 12.0944, and to get to my tool length offset page, I want to press F1. So I'm going to press F1, and I'm going to come to my tool calibration or tool definitions page. I'm going to cursor down to my L. My L represents my tool length, and I'm going to input that number. So it's minus 12.0944. Because I am inputting this information into this page, I need to select the Enter button. Now you will see that my tool length has been registered as my L value in my tool calibrations page. If I want to get back to my happy home screen, and if I want to verify, or if I just want to go back, really easy, I press my Escape button. So I can double check minus 12.0944, minus 12.0944. I have now just taken my tool length for my very first tool, which is tool number 6. Now what I'm going to do is I'm going to bring my Z back up, and I'm going to repeat this process for my remaining tools. So now I've finished touching off this tool. I can repeat the same process for my remaining tools. Again, I just want to say that I'm going to perform a tool change with the doors open. Right now for this video, we do have safety overrides disabled to allow you to view what it looks like inside the machine when the machine is performing this operation. These will be fully enabled when you're in the classroom. Please do not disable any safety techniques. We are doing this strictly for an educational purpose. So this was tool number 6. I can see it here on my spindle. I don't need to take this tool out. I can now put it back into, or it will put itself into my tool carousel, where it will wait until I call up this tool for my machine operations. So again, in order to do a tool change, I press T, and I want to put in tool 7, and I'm going to press cycle start to perform the tool change. So you're going to see the machine has now performed that tool change operation. My tool number 6 is now in the carousel, being held onto, waiting for when we call that tool up again. You'll notice the spindle is empty. Tool 7 is now what we will be working on taking our tool length with, and I can now load my tool into the spindle, and we will continue the process of catching off on my dial indicator until my indicator reads 0. I will set my tool length, and then I will bring my tool back up and carry on with my remaining tools. So I'm going to do 4 in total. right now we have all 4 of our tools loaded into the carousel of our machine. They're all in the proper pockets, so when we call them up in our program, we can say we want, T number 7, and that will bring up our 5/8 end mill. Just by looking in at the tools, you can see the difference in height that each one of these tools is. This is why it's so important that we take tool length offsets, because none of these tools are going to be identical lengths, and they don't need to be. The reason they don't need to be is because we can call up the individual tool length offset when we put the corresponding tool into the spindle. Now we're not quite there yet. We still have one more major step before we're ready to start machining. And that is, we need to find the distance between our indicator plane, or our indicator when the plunger is rotated around to our 0 location on the dial face, and the top surface of our workpiece. We're going to do that by using a probe. Now, these probes are fairly delicate, so please make sure you are using a lot of care when you are using these. The reason that we have to be so careful is, right now, if we go too far on our dial indicator, that's okay, because we have a lot of travel in case we go down too much. We don't have that with our probe when we touch off the top surface of our workpiece. So our next step that we're going to be doing is finding or work shifting between our indicator plane and the top surface of our workpiece. In order to do that, we're going to put our probe in the spindle. We're going to come down to our indicator plane. We're going to set the Z on our control panel to 0. We're then going to come up and over and touch off on the top surface of our workpiece. And because we can use our big Z reference number to measure, we'll be able to input that difference into our G54 fixture offset. The way that these probes work is through magnetism and a small amount of current which travels through the ball into the spindle. So when the probe touches 2 things that are metallic, a buzzer will go off as well as a red light. So if I touch my end of my probe to the shank of my probe with this steel 123 block, you'll see that the indicator starts buzzing as well as illuminating, saying that we have come in contact with the surface. So the first thing we want to do is load our probe into the spindle just like we would any other tool. Just like our previous tools, we're going to move our X and our Y axis above the plunger on our indicator. So we want to move our tool into place. And again, don't feel like you need to rush when doing this. Please take your time. We would rather all of our tools make it out alive and we spend a little more time in the lab than us smashing everything and us having to replace it all and then spending more time in the lab. So bring your tool above the indicator just like you have your previous tools, and you want to come down. Sometimes as soon as your probe touches the indicator, the light and the alarm will start going off. Other times it doesn't. It just depends on the sensitivity and how strong the battery is in each probe. Before you touch anything with the probe, just make sure that you do that trick with either a 123 block or a metallic device and make sure that the probe actually is working. So I'm going to follow the same process, and I'm going to bring my probe down until my indicator is reading 0. So this is where things change from the way we've been touching off our previous tools. With our probe, we don't really care about the distance we've traveled from the machine home position. Really what we are trying to do with the probe is measure the distance from the top of our indicator, or when our indicator is at 0, to the top surface of our workpiece. in order to use our probe as a measuring device, we want to change our reference number to 0. So in order to change your reference numbers, whether it's your X, Y, or Z, we follow the same process. So what we want to do is we want to press our letter address that represents the axis. In this case, it is our Z value. And we want to change this to 0. So really easy, we type in Z0 and then we hit enter. Now, one thing the machine will ask is, are we sure that we do want to make this change? It's basically a safety precaution to make sure that people aren't just randomly changing numbers all willy-nilly. In this case, yes, we do want to make that change, so we're going to hit enter, and you will see that my Z0 is now on top of my indicator plane. So now what we're going to do is we're going to move our probe up, and we're going to move our probe over, and then we're going to come down onto the top surface of our workpiece very, very gently. Our indicator is reading 0. I have now set the Z reference number on my NC controller to 0. So I'm just going to bring my probe up very carefully. I'm now going to move my probe over to my material, which I already have loaded in my vise. Now, one thing that's really important is my workpiece is sitting on parallels. It is important for you to know that my parallels are the same height. The reason I say that is because I have found students will touch off on their top surface and say it's different in different areas. And the reason is because their part's not sitting flat. So that is really important that you have parallels of the same size. So currently I was using 10 thou increments. And I'm just gonna bring my controller over so hopefully you can see everything I'm doing. I'm just gonna move to 1 thou increments, and I'm slowly gonna bring my Z down 1 thou at a time until I hear that buzzing or beeping noise. So you'll see that as soon as I heard that buzzing or beeping, I stopped. And I actually went a little bit too far, so you would have seen that I rotated this in a positive direction. But now every time I move my spindle down 1 thou, my buzzer and light illuminate. Every time I move up 1 thou, it turns off. So I know that I am in the perfect position. Before I do anything else, I'm just gonna move my probe away from my workpiece, that 1 thou in my Z axis, and that's just so you don't have to listen to that buzzing noise over my shoulder the entire time. You're gonna see that my Z is no longer at 0. It's at minus 0.707. This represents the distance my workpiece is from my indicator plane. So one really easy way to adjust all of your tools this amount is by adjusting your work offset number. So when we are programming our workpiece, we're gonna set our datum location of our X and our Y off a corner of our workpiece, and we're gonna name that G54 or a G55 or a G56. We have multiple fixture offset locations available to us. We can also set our Z value with that. So what I'm gonna do is I'm gonna input in my, and I'm gonna use G54, I'm gonna input in my G54 Z axis as negative 7.070. In order to get to my work offset menu, I wanna press the 0 button twice. So I'm gonna press this once and twice, and you'll see I'm at my 0 offset table. I have all my fixture offsets here along the left-hand side. I'm gonna be using my G54, and I wanna set my Z. So I'm gonna cursor over to my Z location, and this is really nice because it's actually written up here in this little menu, and if I just use my thumb, hopefully I'm blocking out the right numbers, you will see it's minus 0.707. So in here I'm gonna type minus 0.707, and then I'm going to hit enter. Now, every tool that reads my G54 will automatically drop down that 707 thou. I often refer to this as work shifting. So by simply doing this, we've taken all of our tool lengths from our indicator plane and we've now adjusted them in our Z-axis to the face of our workpiece. If we want to exit out of this menu and go back to our happy home screen, we just press escape. So now that we've finished with our probe, we can gently bring our probe up. Remember, we want to be on our Z-axis and rotate our hand wheel clockwise. When we're a safe distance above, we can bring our probe up a little bit quicker by using a faster feed rate. And we no longer need our probe in our spindle anymore for tool length offsets, so I'm just going to take it out.